everyone. So in this video we are going to discuss one advanced pigeonhole principle problem which came in Harvard MIT mathematics tournament. And again, those who don't know pigeonhole principle, so just get to know the first and the second, at least the first and the second principle. So or the first and the second form, and I mean, as we are going to need those. So now let's get into the problem. So it's saying that somewhere in the universe, and students are taking a 10 question math competition. So their collective performance is called laughable if for some pair of questions there exist 57 students such that either all of them answered both questions correctly, or all of them answered both questions incorrectly. Okay. So now if for some pair of questions, not all pairs of questions, so some pair, if you have at least like 57 students who have both either answered, or like all those 57 students have answered it correctly or incorrectly, so I would say that the collection is laughable. Okay. Now now we what do we have to do is, like, we have to compute the smallest n such that the performance must be laughable. Okay, no matter how the students performed on the competition. So we have to figure out the smallest n, for which in whatever combination, whatever ways the students answers the questions, the 10 questions correctly, incorrectly, whatever. So the thing is that we are finally going to have one pair of question where at least there will be 57 students who have either all of those 57 students either answered both of those questions correctly or incorrectly. Anyone will do. Okay. Now you would also might ask some trivial questions, like if suppose someone is leaving a question, then that will also be marked as incorrect. Okay. So either you are getting marks or you are not getting marks. Okay. So only two scenarios are possible. So getting marks is correct, not getting marks is incorrect. Okay. So now let's start the problem. So what we are going to do is, we are going to consider for each individual students. Now think that suppose a student has answered k questions correctly. Okay. So out of 10 questions, k questions have been answered correctly, and let's say that then that student will be answering 10 minus k questions incorrectly, where k is basically running from 1 to till 10. Okay. So now then, like, if the student is answering k questions correctly, so how many pairs are forming? K choose 2 pairs are forming, and how many pairs are forming means those pair of questions that student answered correctly. Okay. Now similarly, how many pairs of questions are forming where the student answered both of them incorrectly? So that is 10 minus k choose 2. Okay. So now, to save time, because this solution is going to take a little bit time, so I have already calculated this. So this is something coming out to be what is like k choose 2 and 10 minus k choose 2. So calculating, simplifying it, it's k square minus 10k plus 45. Okay. So now you would notice that we can further write this as k minus 5 whole square plus 20. Okay. So now notice that this is always greater than equals to 20, because k minus 5 whole square is always greater than equals to 0. So now let's try to understand that however the student answers the 10 questions, always I can guarantee that at least 20 pairs will be there, such that each pair the student has answered, if you pick up each pair, the student has answered both of them correctly or both of them incorrectly. Okay. So a combination of incorrect correct pairs, so there will be at least 20 pairs. Okay. Fine. So now if I have basically I'm considering n students are there, because I have to figure out the least possible value of n. So now since I have n students, now each student is giving me at least 20 pairs such that in those 20 pairs, whichever pair you pick up, either that student has answered it both of those questions correctly or incorrectly. Okay, so I'm going to figure. So then, in total, at least I'm going to have 20 n pairs of questions, right? 20 n pairs of questions. Now try to understand that these pair of questions these pairs can be the same, but all I am saying is that these 20 n pairs of questions, at least 20 n pairs of questions, are coming from these n students. Okay, such that if you pick up any pair out of them, like these 20 n pairs of questions, so if you pick up any pair out of them, so there will exist a student who has answered those two questions in that pair either correctly or incorrectly. Fine. So now what I'm going to do is next, now in total, now try to understand that I always say this, that the pigeonhole principle problems are hard. Now when you first learn the pigeonhole principle, the very first principle, that is when you distribute n plus 1 objects into n boxes, so basically one box will have more than one object or greater than equals to two objects. So it's very simple, like a standard one student can understand, but the problem, the difficulty of the problem lies in constructing the holes and the pigeons. Okay, so now try to understand that, as I said, like these 20 n pairs, these pairs may not be distinct, because it might be like there is a student 1 and student 2 who has answered the same pair correctly. Okay, so those pairs are also there. So now what I want is, I want to distribute these 20 n questions in a manner such that basically let me explain. So what I'm going to do is, how many total number of pairs can I have? So I have 10 questions, right? So basically, since pairs are overlapping in this 20 n things, the 20 n pairs of questions I have, as I said, pairs are overlapping. So let me see how many distinct pairs can I have simply. So I have 20 questions. Okay, so 20 choose 2. I have 10 questions. So 10 choose 2. Okay, these many pairs I can form, and 10 choose 2 is basically, if you calculate, it's 45. Okay, so now these 45 pairs that are forming, so they have two alternatives, like those two, each pair can be either answered correctly, both of them, or each pair can be answered incorrectly, both of them. Okay, in a pair you have two questions, so both of the questions can be answered incorrectly and can be answered correctly. So that means I have 45 times 2, that is 90 pairs, because each pair correct, incorrect. Okay, so that's why I am having 90 pairs total. Okay, total number of distinct pairs that can form is 90. Okay, so then what I'm doing is, I'm basically forming those 90 boxes. Okay, so now try to understand that, suppose for example, question 1, question 2. Okay, so suppose I make this box question 1, question 2, that is answered correctly, and the next box is question 1, question 2, answered incorrectly. Okay, so now what I'm going to do is, I'm going to bring those 20 n pairs, at least those 20 n pairs I have, which have been, each pair, if I take out, some student has answered both of these questions correctly or incorrectly. So now what I'm going to do is, if both of those questions have been correctly answered by that student, so that thing I'm going to put that in the corresponding box, because suppose for example question 1 and question 2, there is student 1 who has answered both of them correctly, so that basically has been counted into 20n, so that now goes into that box. Okay, question 1, question 2 correct. So, and also it might be that some student, let's say student ith student, okay, some other student also has answered that correctly, so then also it's going to fall into that box. So what I'm doing is, I'm distributing these 20 n pairs that I have collected, at least these 20 n pairs that I have collected from n students, okay, such that each pair either has been answered correctly or incorrectly by those students. Now I'm distributing in these boxes. Okay, so now try to understand that it's basically in so finally when the distribution is totally done, when you see a box, so basically suppose in this box you see that two entities have like two out of 20 n objects, two objects went there. Okay, so what do you actually mean? So that means there are two students who have answered that correctly. Suppose if in this box you finally see that there are three entities which went into that box, because there are 20 n pairs. Okay, so now you are seeing that 20 n pairs, you pick up each pair. Okay, this pair, question 1, question 2 answered correctly by the student. Okay, you go into this box. Answered incorrectly, you go into that box. Okay, like this. So now if I see that three entities went into this question in the second box, question 1, question 2, which answered incorrectly, so that means I know that there are three students who have done this. Okay, that is answered question 1 and question 2 incorrectly. So this is the basic. I'm going as basic as possible. Still, if you can't understand, so pause the video, think about it, and again rewatch it. Okay, so now let's continue. Then let's come into the pigeonhole second principle. What does it say? That is, if I have, suppose, n boxes, and let's say nt plus 1 objects or pigeons which I want to distribute in these boxes, then what do I get? I get, basically I can say that there will be one box which will receive greater than equals to t plus 1 objects, right? So n boxes, t, even if you put then nt, then also you have one object. So at least, however you place, at least one box will receive t plus 1 objects. Now try to understand. Similarly, I am distributing these 20 n objects out in these 90 boxes. So what can I say? So my number of boxes n, which is don't confuse n with the number of students. This is what I told about the second form of pigeonhole. Okay, now here how many boxes do I have? 90. So 90 t plus 1 objects. Okay, let's say that I'm distributing this is the total number of objects. Okay, and that is basically 20 n. So what is basically t? So t is 20 n minus 1 divided by 90. Okay, and let's take it might not be an integer or whatever, it might be integer. So to be safe, let's take the floor function. Okay, so now t is this. So now since I know that my second form is saying that at least there will be one box receiving, so 90 boxes, 90 times t plus 1 pigeons are being distributed. So at least one box will have t plus 1 pigeons. Okay, so t plus 1 is 20 n minus 1 divided by 90 floor plus 1. So now according to the condition, as you see that one of these boxes will have at least 57 students. Okay, so then what I know is that I should get some at least one box is receiving these many students, right? Out of these 90 boxes, one is receiving these many students. So according to my criteria, this should be greater than equals to 57, or you can equate it to 57 as well. Okay, so because we have to basically go for the least case, so let's equate it to 57. So then again I won't take much of the time. So I have already you can easily solve it. So yeah, basically, so what we have is 20 n minus 1 divided by 90 box should be greater than equals to, if I take that 1 on the other side, 56. Okay, so now again so yeah, let's take it greater than equals to 57. Okay, so now I have solved it. As I said, n is coming out to be greater than equals to 253. Okay, so you can easily solve it, there is nothing much. So n is equals to 253. So now what we can say here is that if 253 students are giving the exam, where the exam contains 10 questions, so there will be a pair of questions where at least 57 students have answered that correctly or incorrectly. Okay, now the question is asking that find me the smallest n. Okay, so if now many students like I have seen that even they think that we are done here, right? So no, you are only guaranteeing that for 253 you can do this, whatever be the condition. But how do you guarantee that 253 is the least? So for 252, so for n equals 252, let's show that we have a case where it doesn't hold, because for 253 I'm guaranteeing that blindfoldedly, just mark these 253 students blindfoldedly, however they answer the questions, always my condition will be satisfied, right? So that I have to show that for 252 also it can happen, but is there any one case where it doesn't happen? So if I can show that only one case where it doesn't happen, so I am basically able to prove that for 252 or however the students does gives the exam, the condition may not hold, because I am showing that one such scenario is there. Okay, so now let's I have to construct the scenario. Now notice that 10 choose 5 is 252. Okay, so what we can do here is, like, we get the idea, that is, like, try to understand, I have 252 students and 10 choose 5 is 252, so that means 10 questions. Now if I try to form 5 set of 5 questions, so how many different set of 5 questions can I form? 252. So what I'll do is, like, I will give each of those 5 set of questions to individual student. I'll assign those 5 set of questions to individual students, and so I will construct this scenario, that is, they are answering those 5 questions correctly. Okay, so that what does that mean? That every student is answering 5 set of questions, and no 2 students are answering the same 5 set of questions correctly, because I have different 5 set of, yes, intersection between 2 sets, there might be 2 similar questions, but all 5 questions will not be the same, because 10 choose 5, I have 252 different sets having 5 questions in them. Okay, so I'll assign one to each, and I'll make the scenario that they are answering those 5 questions correctly and exactly, and the rest they are doing they are answering it wrong. Okay, exactly those 5 questions correct and the rest incorrect. Now try to understand that if I take any pair of question, okay, so let's say that QI and QJ question. Okay, and if that confuses you, let's write it as simply, let's write Q1 and Q2. Okay, so we can talk about any pair. So suppose Q1 and Q2, I want to now check that how many students can answer this question correctly or incorrectly. So first let's come to correctly. So suppose if a student, like, I want to calculate how many students have answered this correctly, right? So now try to think those students who are answering question 1 and question 2 correctly, they are overall answering total 5 questions correctly. So now with this, they need 3 questions, QI, QJ, QK, which they need to answer correctly, and the rest wrong. Okay, so now those 3 questions can be chosen from the remaining let's say from the remaining, how many questions do I have? 8 questions. So from the remaining 8 questions, 3 questions can be chosen for this set, and that is basically 56. So what I know is that there are exactly 56 students in this scenario where they have answered question 1 and question 2 correctly. Okay, and the same thing, like, if question 1 and question 2 are being answered incorrectly, how many students are there? So basically again each student have got different 5 set of questions where totally the sets are different. Again some questions can be there common. So each question, again the same scenario, if I want to know question 1 and question 2 how many students have answered incorrectly, so that means what? Again with those 2 questions, 3 questions should be there, that is they should have answered incorrectly. Again, that those 3 questions can be chosen from the rest 8 questions. In 8, choose 3 ways, which is 56. So for this example, any pair of questions, not only question 1 and question 2, any pair of questions you pick up, the number of students who have answered it correctly is 56, and also the number of students who have answered it incorrectly is also 56. So none of the pairs have 57 students who have either answered it correctly or incorrectly, and so 252 doesn't work for this scenario, and so for 253 is our answer, and it's the smallest which works. Okay, so I hope you have enjoyed the solution, and if you still have any doubt, you rewatch it, and you can comment down below. And if you like the solution, so please don't forget to put a like, and yeah, please do share it among your other friends who are interested in such problems. And that's it for this video. So thanks for watching, and keep watching and keep learning, and see you in the next one.